Hey, this is a video that's going to review the four different areas, different formulas for area that we have been using in the book. And the first one is the rectangle. Now, a rectangle consists of a length and a width. Length over here, and a width over here. It doesn't matter which one it is, but there's kind of the idea of a right angle right there. And when you want to find the area of a rectangle, you use the idea of area equals length times width. This is 4 in length. So what I'm going to do is I'm going to take the length of 4 and substitute it in for the L here. I'm going to put it parentheses because I substituted it, and then my W, or my width, 1, 2, 3, 4, 5, is 6. So I'm going to put a 6 in here as well. And when you have numbers that are butted up against each other like this, and there's nothing in between them except parentheses, or they're just written next to each other and there's no symbol like addition, multiplication, division, or subtraction in there, it's multiplication. So this is 4 times 6, which is 24. And then, since I'm not given any measurements here like feet or centimeters, I'm just going to call it units. Okay, I'm just going to call it units for right now. And the units, since we are dealing with area, is a two-dimensional idea, so it has a length and a width. And if you look in here, if we actually counted them, there would be 24 squared units, or 24 units squared. So everything in area that we mark for area must be in units squared. Triangles are a little funny because they don't, here's a length, but we're really going to call this a base. And it has a height or a length over here. We're going to call that a height because it makes it easier for us to think about triangles if we're not really looking at a length, but we're looking at how tall they are. So we're going to call that height instead. Again, we have a right angle between them. They're perpendicular to each other. And what it turns out that if we look at the area of a triangle, we're going to use base times height first, but then what ends up happening is this was base times height. It would actually make a rectangle just like it did over here. It would make a rectangle, and this here would be 4 and the height would be 6, and 4 times 6 is 24 just like it was over here, so there would be a rectangle made with these two. However, we only need half of it because this triangle up on top is the same as this triangle down here. So really this triangle ends up being half of the rectangle that was there if we hadn't drawn the diagonal. Instead we drew these out this way. This works the same way for all of these triangles. So this is a triangle over here with a base and a height. This height just happens to be inside the triangle. Okay, but it's still, this is going to be 4 times 6. And if you look at this triangle out here, it is the same size as the triangle that's inside over here. And this triangle here is the same size as the little triangle inside. So we still end up with half of the area, the length and the height, or the length and the width, or the base and the height. Again, here is also a base and a height that is perpendicular, and the triangles that are outside, this one out here is the same as the one inside, so that's half and half, and this one out here is the same as the one that's inside, so it's half and half. So this ends up being half of the rectangle, half of the rectangle, half of the rectangle that would have been there. So when we look at area equals base times the height, really what we need is 1/2 of the base times the height. And in this case the base is 1, 2, 3, 4 long, and the height is 1, 2, 3, 4, 5, 6. So this would have been the rectangle that we had over here. However, we've cut it down into half, and then all triangles are half of the area that would have been there if we just made the rectangle to begin with. So the area formula for triangles is just half the area of the rectangle. So I'm going to substitute what I need to here. There's my 1/2, I already know that one, and then my base is 4, my height is 6. We can do these in whatever order we want to because of the associative property of multiplication. It doesn't matter which ones go first. I can do 4 times 6 is 24, half of that's 12. 4 times 1/2 is 2, times 6 is 12, half of 6 is 3, times 4 is 12. So I'm just going to leave this and just go with the 1/2, and then 4 times 6 is 24. I still need to have it in parentheses because I have to have something here that shows that these two need to be multiplied. And then half of 24 is the same thing as 24 divided by 12, and again we are units squared. This is half of this. Okay? This is a parallelogram. Now parallelograms are kind of tricky because they have, again, a base down here that looks like length, but there's really no length because it doesn't go all the way to this. And if I multiplied this whole length or width or whatever we want to call this side, I can't go all the way out there because there's really nothing out here. There's no space out here that we're taking up. What we're going to do is we're going to have to go this way again and make it a height. Okay, base and a height. And so this base and height are going to work the same way that if we had a base times a height, if we had figured out that the height was over here and we multiplied it by this base, it would be right here like this. Well, it turns out this triangle over here, this is 3 by 4, is the same as this triangle. So if we just multiply base times height over here, we count this, it's not part of the shape. And we missed this part, but it's the same as the stuff that we just counted. So it turns out this is just area equals a length times a width. So this formula is really this formula. It's just called different things. The base and the height instead of the length and the width. It's still just two numbers multiplied by each other. And here the base is 5, and here the height is 1, 2, 3, 4. So I'm going to put 5 in for the base, put a parentheses, 4 in for the height. 5 times 4 is 20, and it's going to be units squared. There we are. Now, if we're looking at a circle, circles are a little trickier because what we're messing with is, with all of these things, we're making perpendicular relationship between the two things that we're going to multiply. Well, here we don't have anything that's perpendicular. So what we're going to do is we're going to make a perpendicular relationship by looking at the radius and squaring the radius. So we're actually going to take the radius and multiply it by itself. And that creates a perpendicular situation. And that is how we start our area problems. There isn't an area you can calculate if you don't have a perpendicular relationship between the two numbers that you're multiplying. This is why we have to take the radius, because it's the only thing we can know about this circle. I mean, it's all the information that we can have. Then we can find the diameter and the circumference if we use our other formulas, but that's what we're doing right now, is we're just looking for the area. And we need two things that are multiplied by each other, so we're going to square the radius. The formula for the area of the circle is pi r squared. So when we're looking at pi r squared, we're going to use 3.14 for pi. Let's see if I can't get my calculator on. There we go. 3.4 for pi, and I'm going to substitute the things that I know. Well, 3.14 for pi, and then r is 1, 2, 3, 4. So I'm going to mark that 4, and 4 needs to be squared. So 4 squared means this needs to happen before I can multiply this. Pi never gets squared. We never square pi. Pi is the relationship for how far this is the relationship between the length of this line and how far it goes around the circle halfway. It's also the relationship for the diameter to be wrapped around the circle. It never is squared. So we always square the radius, and if we're going to continue this problem here, it's a equals 3.14, and 4 squared, 4 times 4 is 16, and 3.14 times 16 is 50.24, and this is units squared. Now, what am I going to do over here? Because a lot of the problems that we're going to be looking at have this circle in it, and all we need is half of the circle. Well, this formula gives us the entire area of the circle. All we need is half of the area, so now what we're going to do is we're going to take that 50.24 and we're going to divide it, we're going to divide it by 2, or cut it in half, and this ends up being 25.12 units squared. So the idea here is, what are we looking at? What shape are we looking at? Which shape? Are we looking at a rectangle? We're doing area times width. Looking at a triangle, we're going to start with area equals 1/2 base times height, which is just a rectangle formula cut in half. If we're looking at a parallelogram, we're going to go with area equals base times height, which is really the rectangle formula. These three things are pretty much the same formula. That one's just half of it. And then with the circle, of course, it's a special idea. A equals pi r squared. The radius gets squared first, and then we figure out how much of the circle we're going to need, because a lot of the problems have a circle on top of a square or a rectangle, where they'll just have the circle on both ends, and you'll need half of the circle up here and half of the circle on the bottom, which is really the entire circle. Okay, so those are really the 4 formulas that you need to be messing with. These 3 are the same. That one's cut in half, and this one is special. Right? This will help you on that homework. Thanks.